Hi everyone, we're going to look at exploring continuous data using SPSS. Just as a little reminder, continuous data is quantitative data. It's numerical data. It's usually indicated between interval or ratio types of data. Interval data has no true zero. It may be represented, it may represent values below zero, have negative values. A temperature can be negative temperatures, but there's never no temperature. There's always some kind of temperature. Ratio variables are interval variables, but with the condition that zero of the measurement indicates that there's none of that thing, right? You can have zero income, right? We've all been there. In SPSS, these types of measurements are typically associated with these symbols for categorical data, which is also nominal and ordinal data. It has the little bubbles and the little histogram pictures, and for our continuous data, it will be associated with these little rulers. If the data is string data, you will see the little A next to it. If it's date data, you'll see a little calendar, and if it's associated with time, you'll see a little clock. Okay, so our data is just some various demographic data. We have, there were questions asked of people about their age, marital status, income, and so on. And so we're going to do an explore on our data. And what you would do is click Analyze and go to Descriptive Statistics, Explore. And so let's go ahead and look at age and years at current address and click OK. So right off the bat, you'll notice that we get a chart that tells us how many people are in our sample. There's over 6,000 people, and you'll see it has the mean as well as a trimmed mean. And a trimmed mean is what the mean would be if you trimmed the top and bottom 2.5% of cases off of your data, and that would be what you would be left with. 41.78 would be the mean instead of 42.06. And this can help eliminate extreme outliers. And it also produces, your median, variance, standard deviation, and so on. The years at current address, you'll notice when they trimmed the mean for this value from 2.5% of the numbers from the top and 2.5% of the numbers from the bottom, the trimmed mean is much lower actually than the mean without doing so. So there could be some outliers here in the years at current address. And then we get into the stem and leaf plot here. And the way we read this is you would say that for this sample, there is one 18-year-old and 4 19-year-olds. And then there's 5 20-year-olds, and so on. However, when you look here, you'll notice that each leaf actually represents 10 cases. So in actuality, there's 10 18-year-olds and around 40 19-year-olds. Continuing on. Then you get the box plot, which shows a fairly normal distribution. This line in the middle represents the mean of scores. And the years at current address, you'll notice it looks quite different from the stem and leaf plot for the age. If you turn this right side up, this would look like a normal bell curve, correct? But if you turn this one right side up, it would be skewed. And you can see here with this box plot, it is indicating that there are outliers. These little circles indicate which cases are falling into extreme scores. So that's very handy. Another neat thing about using Explore is you can split your data. So let's go back to Analyze, Descriptive Statistics, Explore, and let's split it by gender. Gender, and put it in the factor list. Now we'll be able to see age and years at current address for each gender. And also, it's good to look at your data more closely, and you might look at it for outliers. And let's see, histogram. And let's ask for some normality plots to look even deeper into this data. Click continue. Let's see what the options. This is a way it produces the data. We'll just keep that at default and click OK. Okay, so now you can see age and years is split between females and males. There's there's 3,179 females and 3,221 males. And now it gives our descriptive statistics for females and males, all of the same ones we've seen before. And it does the same for current those in the current address. Now, since we asked for extreme scores, it's showing you what the highest 5 scores are for females and the lowest 5 scores are for females, or and likewise for males. And when you see the little A's, the little letters next to it, means there's more than 5 cases at this score. There's more than 74. Okay. Here are the tests for normality. These here, since they are significant, significance would be considered anything less than 0.05, and this happens to be less than 0.05. And that means we have non-normal data. But since we have such a large data set, over 6,000 cases, you will end up with a significant score regardless, or you typically would. So really, these tests for normalities on large data sets become meaningless. So just keep that in mind. They are helpful for smaller data sets. And here we can see a histogram now, and you can see this bell curve for females, and it's looking a little better. It's a little skewed on the younger side, right? Same with males. And here are the stem and leaf plots. And now you can see it's showing, it's telling us that we have a few extreme outliers that are 76 years old. And these normality plot, these QQ plots, quartile plots, are similar to like PP plots. And you can see it's normal. It follows the line pretty much in the middle. But towards the upper end and lower end, there are some outlying cases. Same with the males. And here you can see the box plots. Case 1998 seems to be an outlier for this age and gender here. And we can see that this one is certainly very skewed for the years at current address. More people have spent fewer years at their current address than those that have spent more years. Same with the males. And you can see the same, as you can see, these, if you turn these stem and leaf plots up, right side up, they would look similar to these bar chart or these histograms. And these are a lot less normal because our data is skewed, as you can see by the histogram. And you can see quite a few outlying cases in this data. All right, thanks for listening. It's good to know your data inside and out, especially if you're doing, a big project. and I catch you next time.